Hey everybody, this is Larry, this is me going Q4 of the Bi-Weekly Contest 112, count K-Subsequences of a string with maximum beauty. Hit the like button, hit the subscribe button, join me in Discord, let me know what you think about this poem. So this one's a little bit tricky, but to be honest, I started out these videos with almost like a retro of how I did, right? Because, I mean, if you want to see an explanation there, or just the explanation and nothing else, but there are a lot of other videos, but what I would try to do is bring my perspective because there is always a difference between understanding the solution and understanding how to get to the solution so that hopefully you have a way to get there next time, right? Because just like I think I do, maybe I'm speaking for myself that I do this a lot where sometimes I when I'm learning something, I'm like, oh yeah, or like I watch a video learning something, I'm like, oh yeah, nod along, but then your brain is not being active, you're doing passive, right? And it's not always good enough to be able to solve this problem next time I see it or something, right? Other than memorization, but that's not what we're trying to do. We're trying to work on our problem solving skills, right? All right, anyway, so a little bit of a long preview, but yeah, for this one, I actually, to be honest, and some of this is me during the contest. For this problem, I knew that I had a slower Q3. Usually I'm faster on the Q3, so when I'm a little bit slow, it just means there are different Qs, right? And what I mean by that is that for when I got to this problem, I was about probably like by my estimate, like 3 minutes behind the top people, and as a result, I should expect to see some people starting to solve this as I solve this, so that I could kind of get a gauge as to the difficulty of the problem, right? And to be honest, I think I kind of messed up on that particular thing in that I overestimated difficulty here, and that was kind of what led to the slower time. And you can watch the live portion of it because I think I actually got this problem. I mean, maybe I was a little bit slow on the reading because didn't sleep enough last night, was out partying a little bit too hard, but so I was a little bit sluggish on the reading. There's a lot of words, but to be honest, yeah, after that I was like, I think I got the idea pretty quickly. I confused myself a little bit in a couple of places, but maybe I'm just sluggish today, but otherwise, I should have done this much quicker, and then I end up with a silly mistake because I don't know. It's just one of those days. So yeah, but let's get to it, right? So the core part of this problem is, it's combinatoric. So the first thing is noticing that you have to return mod. I'm glad I didn't made this mistake on forgetting to mod, though it has happened many times. This particular problem, it becomes greedy. What do I mean by that? Well, first of all, we should calculate the max, right? Or figure out how to calculate the max. The first thing is knowing that f of c for some character is actually equal to the number of times that the character occurs, not just in the subsequence, right? So that means that f of c doesn't ever change. So that means that let's say we're trying to find a K subsequence. So we're trying to max K, right? Then what does that mean? That means that, let's say we have some F scores. We don't have, at this point, we don't really care about the characters itself because all it matters is the number of times that they appear, right? But let's say they appear like 5, 6, 1, 2, I don't know. I'm just banging on the keyboard, really. In this case, then all it's saying is that what is the max score? And remember that all the characters have to be unique, so you don't have to worry about doing the same character twice because that's just counted in, right? The constraints are really kind of, I don't know, tailor-made. So basically, given K, this is just saying, okay, give me the top K. Like we're trying to we're trying to maximize the sum of these scores where you only can take the k of them, then it just becomes top k problem, right? Because here, then let's say we sort them, we get, what is it, 1, 2, 2, 5, 5, 6, 8 or something like this. So then now we just take the max elements because, well, that in that way this is greedy. If you want to get the maximum sum, all you have to do is to get the maximum elements, right? Hopefully that's fair enough and that's simple enough for me to without going into more detail, but that's the idea. And then the next question is how many count are there? We'll go over that in the next, but well, yeah. So let's say k is equal to, I don't know, k is equal to 3, right? Then what does that mean? Well, we always have to, and we're trying to maximize the score of k is equal to 3. Well, we always have to take an 8. There's no decision there because, well, you just always have to take an 8, right? Because that is always going to be part of your answer. In the same way, that's going to be true for 6. But the 5 is where it gets interesting here, right? Because now, and maybe for visualization, I'm just going to give some captures, right? Right, just for visualization. But for here, we already are forced to take an F, we already forced to take a G, then now we have to take one of the 5s, and we could take either a D or a E. So that's basically the question, right? D or E, right? And now that just becomes the count. So how do you calculate this? Well, how many Fs are there? Well, we know, I guess I kind of didn't, let's do it in this order because, yeah. How many Gs are there? Well, we already know that there are 8 Gs because, well, they kind of reuse the score, so it's a little bit the quote unquote the beauty and all this thing. They reused it twice for the score and the count, so it's a little bit confusing maybe. That's how I got a little confused, to be honest. Anyway, but that means that there are 8 Gs, so there are 8 ways to do it, right? So there are 8 ways, and then how many ways are there to do an F? Well, there's 6 ways to do it, so there's 6. And then now, however, this D or E, so how do we do it? Well, we have 2 things, D and E, and we have to choose one, right? And that's really the answer. We have 2 things, we have to choose one, and then so we have to choose either the D or the E, and there's 2 choose one of saying it, and then for each of those, well, they're the same because their count is the same. There's 5 ways of doing it. So that's basically it. And then you find the product of all these things all together, respecting the mod, and that's your answer. Yeah, that's pretty much it, to be honest. Because everything is based off greedy, and basically if you have a tie, you have to choose some amount of them. And this, of course, can change because if you have, say, this is 5, 5 as well, then now you have 4 choose one because of those 4 characters, you have to choose one of them. If k is equal to 4, now you have 4 characters, you have to choose 2 of them, but the count is still going to be 5. Or, well, in this case, the 2 5s, so it's going to be times 5 times 5, right? That's basically the idea. And let's say even if this is an 8, then you have just an 8 here. So there are a couple possibilities, but that's the idea. That's the observation. That's the visualization behind this problem, right? The implementations could be a little tricky, but yeah. There is an edge case where you have... Yeah, there's an edge case where... k is greater than the number of distinct characters. For example, if s is all a's and k is 2, even if n is equal to 2 times 10 to the 5th, the answer is 0, right? That's how I got my wrong answer anyway. I thought about that case during the contest, but then I was so focused on the other parts that I didn't really... I forgot it by the time I got to the end, I think. So yeah. Anyway, so let's go over the code. I kind of did this in a funky way because I kind of took a wrong path with respect to tie breaking. So I thought that I was going to have to do this part of dynamic programming, but then I end up not. So I kind of left the structure, but I probably could have done this more cleanly, just to be clear. But yeah, But basically, first take care of the mod. This sets up the frequency table, and then now, and as we said, we don't actually even care about the characters. We care about only the values. So then we sort it. We convert it to a list. The sum is going to be, and I actually don't even use this, do I? Huh? I thought I would, but then I don't. So never mind. I don't even use this. So I just skip it. Initially I used it, but then I was like, this makes it too confusing. But anyway, so the way that I did it for tie-breaking purposes is that I guess I could have used it instead of doing it this clunky way, because I think this way made it a little bit confusing. Because if I did it the other way, I could have just took the max and then subtracted by the things that we're doing, and then that made this a little bit easier. But in any case, yeah, I did a frequency table off the frequency table, so that, for example, in this case, I put all the, it's one way for me to group all the 8s together and the 5s together, so then I could do this part in a easier way together, and as you'll see in a second, hopefully. But yeah, but I saw this as well in reverse order, which I didn't. I also made a mistake here, but yeah. So basically, this is the key. This is basically the count. So basically, this is, for example, this is saying that we have 2 8s. So C is 2. This is the number of Ks we have left. It is self-explanatory. If we don't have, if we have more characters than we have left, then we just choose a subset of them. This is equivalent to here we have 4 choose 2. So basically, if we have four characters that are dupes, but we only need 2 of them, so we choose 4 choose 2. This of course is equal to the key is a little bit odd, but this is saying 5 to the power of 2 left, and then we do a mod power just because it's easy. This is a little bit trickier to write in other languages because this may actually overflow because this can be up to 26. So initially I actually also thought that I miscounted. I thought C could be like what's it, 2 times 10 to the 5th. So I thought that I may run into overflows even in Python, because in certain cases it may just take too long to calculate, right? Because you don't do enough mod. But then I was like, oh wait, no, this is the frequency table of the frequency table. So that means that this is only up to 26. So at worst, this is 26 choose 13, which has a lot of digits, but not that bad. Like, you know, yeah. So that's why I kind of did it this way, and then remembering to mod, and then remembering to subtract. The reason why I had to subtract is because I have to do a check later. I guess I could have just do a return statement here as well, but either way. Yeah. And then if we have anything left, then we return 0 because we still have to do more characters. Otherwise, we return the count. The base case, of course, is just that we do K to the C. This is equivalent to, say, 8 to the power of 2 with some mod. Yeah. That's all I have for this one. There's a lot of sorting, but all the sorting is on alphabet. So this is on 26 things. This is on 26 things. So yeah, all this is going to be, I don't know, alpha log alpha. This takes linear time because that's the size of the input. So you have to take linear time no matter what. But it's going to be linear time plus alpha times alpha. And this is just O of alpha. The mod power stuff is also maybe O of alpha, depending on how you want to count it. So at the end of the day, you know, this is going to be pretty fast. It's on the order of like alpha log alpha times alpha, or maybe alpha square log alpha plus n is your time, and your space is just going to be linear plus alpha. When I say alpha, I mean the size of the alphabet. In this case, is 26. So yeah, that's all I have for this one. Let me know what you think. Let me know how you solve it, and yeah, you can watch me solve it during the contest and struggling and making all these mistakes. I mean, to be honest, even now I'm struggling to keep my eyes open because I need more sleep. So yeah, you can watch me solve it live in the contest now. Did I put it in? Okay. Why was I so bad at that one? So slow. So many typos. Should have been faster. Okay, focus. Oh no, count K-subsequence stuff. How am I doing? How many people got this one? 271. That means I was really slow. I knew how to do it, just didn't do it. Alright, let's see. Subsequence of link K, and all the characters are unique. What is N? All his characters are unique. Oh, I see. Of link subsequence of link K. Okay. People haven't done yet still. Couple minutes on top of me or ahead of me. F of C is no time. Sum of F of C of every color. Okay. K is equal to 2. Mod, I guess. F of C is the number of. I see. Oh, okay, then we should get that first. I need not fully awake. Okay. K is equal to 4. So that means just that. Number of case sequences with maximum beauty. Okay. So we have to figure out the maximum beauty and then figure it out. What is the maximum beauty? Does this ever change? Oh, it's of sequence 2. So you sort it, right? When do you ever not sort? I'm a little confused, but okay, so and then you do a DP on it. Now it should be greedy though, right? When is it not greedy? Is the count not greedy? Count. By definition, okay. I see that if you can have more than thing, right? I can see why this is confusing, but I think it's just greedy on this part. I don't know how it cannot be, but what is it? No. So it should be return 3 and 5. Okay, that is what I expect. And then the tricky thing is now could have multiple if you have to choose two of these. Right. It goes up to 10 to the 5th, so you can't do anything too well. It's only 26, so I think that should be fine. 26 times 2 times 10 to the 5th. But you don't need to do that, do you? I'm surprised no one, well, one person got it now, but I'm surprised it took that long. Maybe China's got it more. But we don't even need the values, do we? Okay, so the thing is about the tie breaking. So it's the number of ways. So we don't need the max anymore. What we actually need is just the tiebreaker. So what does that mean? We have to calculate. Okay, so oh, I think I could just right, and then now basically while and this has only 26 elements. That's right. That's why in a dumb way, and then if it whatever. If this is greater than or equal to 2, if v of 0 is equal to v of 1, or if this is how do we say this in a better way? For I am going to be if v sub I is not equal to v sub I minus 1, then okay, and then now if v sub I is equal to 0, then all the things that are tied, if max is equal to 0, just in case, then everything that's tied with v sub I we should count, right? How do I write this in a good way? I think I just need a second frequency table, that's all. So we have K, okay, fine. Oh, that's right, K. And this should be reversed. Oh wait, no, I did the reversing. So V is, oh, it doesn't matter. Okay, so in this case, it does matter what the value is. We want to sort by the key, right? Well, we have an hour. I think we could do it. Okay. count. If k minus c is less than 0, then this is the thing, right? This is the thing that we have to care about. If left minus c is equal to otherwise k left minus c, and then we have to do a count. What is the count? We don't have option here. We choose one of the things, and there's only f of, well, there's c way of counting it, so then we should just do that. I think that's fine, except for this case. K left. What is K left? Oh, this is the count of count, not this. So it's actually times key to the C. I forgot the mod for last time. Okay. Yeah, and then that's basically how many K's left. Okay, and then if this is, we have to do type working thing. So now we have to do K left choose C. Just do DP, right? Do K left choose, no, we have to choose C, choose K left. We have C things, we have to choose K left of them, and oh, they all have the same count. That's right. What is C again? C can go up to 10 to the 5th, so maybe I don't. K left can only go up to 20. I probably would DP this bit. Okay, so each of them is key times, or key to the C, K to the C, K to this, is that true? That is the number. What is key again? Key is the number of count in the original thing. Too many layers. Too many layers. How many people have gotten this? Oh wow, a lot of people have gotten it. So I'm really behind. That's number of ways to choose it times power of key C mod. No, it's my K left, because that's how many numbers are left. Okay. It's n factorial, right? So oh, you have to do modular inverse stuff, do you? If you don't do it, if you DP. Let's do DP then. Key is the number of, and C is the number of times it appears, so it must at most 26, And K left is 26, so it's only 26 squares. So okay, fine. I'm a little bit slow. So wait, if it's only 26, then I don't need to do DP. Only do it once, so okay, fine. Okay, then I could just do binomial, right? What is the function for it? Binom. Choose. I forget what it is. Choice. Comp. Oh well. Yeah, it should be okay. I mean, it's only 26, and you only do it once. Okay. I mean, but it's not right though, so that sucks. Not right because this is 0. I don't know why it's not 0. Okay. 1 and 2 still wrong. Why is it 1? So we have K is equal to 2. 78 pure got it now. Well, just a slow contest today. Sluggish. C choose K left. It should be 2 choose 1. 1 choose 0 is not what I expect. So maybe that's the second part. Oh no. 1 choose 0. K left is 0. If K left is 0, then we're Gucci, right? So K is equal to 2. That's not what I expect though. Count is equal to 1. Am I doing it wrong? You have one thing of count 2 and 2 things of count 1. Wait. Yeah, no, that's right. One thing of wait, is it? No, one thing of count 2. Okay. Yeah. Did I do this in the wrong order? I did this in the wrong order, that's why. Reverse. 4 and 2, okay. Is this worth YOLOing? I don't think so, to be honest. Okay, so let's say I have what's K? And we choose 1, and then that's 2. Was that 7 choose 2? I mean, this is fine, but then I don't know what the right answer is, so like if I have this. $84, is that right? It's 21 and then 4 on each one, so I guess that makes, or 2 on each one. YOLO. Oh no, oh well. Why did I choose 2 on this? Oh, because if K left is, I actually thought about this, but then I forgot. Oh, Oh, well, that's because I don't do K left. Sloppy. Okay. Okay. I could have made up some time if I wasn't sloppy about it, but I think that's fine. It's a kind of a weird contest for me. Like, Thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this farm, this explanation, and how do you do on this contest and everything. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye bye.